With this 3 by 3 system, so we've got 3 variables, x, y, and z, and 3 equations. That's sometimes called a 3 by 3 system. What we can do is use 2 of the equations to begin with, eliminate one of the variables, and then we would have a system that has only 2 equations and 2 variables. And then we can solve that by substitution or elimination method. So the first thing to do is decide, well, which of the variables do I want to eliminate? I need to eliminate one of them. And I think that I'm going to use the x's, because if I use the last equation and the first equation and I subtract them, the 2 x's will cancel. I could also use this equation and just multiply by a -2, and then it would cancel that x as well. So start by eliminating the x's. So if I use the top and the bottom equation, I sometimes even like to label them as the top equation, the middle equation, and the bottom equation. So if I use equation A and C, it's going to be a 2x minus 3y plus z equals -1, and a 2x minus y minus z is equal to -3. And if I want these 2 x's to cancel, then what I need to do is subtract the 2 equations. So in here there's going to be a 2x minus 2x, those are gone. Keep in mind this negative needs to be distributed, so this negative multiplied over here is going to be a positive y. That positive y combined with -3y is -2y. And with the z's, the negative and negative will make a positive z, with another one makes 2 positive z's. And for the constant, this also has to be multiplied with the -1. So we've got a +3 subtract 1 is 2. Okay, now we've got one equation that has y and z in it. We need to repeat that. Go back to the a, b, and c, and I chose to use a and c, and I got an equation that has just y and z in it. Well, I'll do that again with either a and b or b and c. Just don't use a and c again. I think that I'll use a and b. So if I use a and b, well, in order to get the x's to cancel, I'm going to need to multiply this one by a -2. So I can indicate that here, that I'm going to be multiplying the second equation by -2. So the first equation is 2x minus 3y plus c equals -1. And the second equation, multiply by a -2. And you can either do it as I did here, just put the number in front and then distribute it later, or you can go ahead and do it as you're transferring this down. So multiply this by a -2 is -2x, multiply this by a -2 is -2y, multiply this by -2 is +8z, and multiply this by a -2 is a +18. And then combine like terms. So these are going to cancel. These will make -5y. In here it's going to be a +9z, and then equals a 17. So now we've got two equations that have just two variables, y and z. So now we can put those together and solve for y and z. Well, I noticed that with this equation, it's got a 2, a 2, and a 2, so I could simplify that one, divide everything by a 2, and we've got negative y plus z equals a 1. And then take this equation over there, negative 5y plus 9z equals a 17. And I think that I'll continue using the elimination method. I'll get these z's to eliminate. So multiply this equation by a negative 9, and that will get the z's to be eliminated. Combine like terms. So in here, a negative times a negative is going to be positive 9y, and a positive 9y subtract 5 will be 4y. And this will be negative 9z, which will cancel that. And then there is a negative 9 times 1. So negative 9 and positive 17 is 8. And there we have it. Y seems to be equal to 2. Now, take that information and substitute it into one of these two equations that have y and z, and we'll be able to find z. And so we have, I'm going to use this equation that looks to be the simplest, negative what y is equal to plus z is equal to 1. So just add 2 to both sides, and we've got that z is equal to 3. So we have the y is equal to 2 and the z is equal to 3. And we're almost finished. Now I need to find x. Well, it was back here that we had equations with x. So go back to one of these, whichever looks easiest. I think that one, the middle one. And then find x. So finally, use equation B to solve for x. So it's going to be x plus whatever y is equal to, a 2, and then minus 4 times z, which is a 3, equals a negative 9. So this is going to be a negative 12 with a positive 2 is a negative 10 equals negative 9. And so add 10 to both sides, and it's going to be 10 minus 9x is equal to a 1. And then finally, because this is a point in space where these three planes are intersecting, write it as a point x, comma y, comma z. So it's 1, 2, 3. Now to check, what I should do real quick is check. I know that it works for B because that's what I use down here. I should also check that it works for equation A. So use a 1, a 2, and a 3. So 2 times 1 minus 3 times 2 plus the z value of 3. Does that equal a negative 1? So this is going to be 2 minus 6 plus 3. Does that equal negative 1? Well, that's going to be a positive 5 and a negative 6, and so the answer is yes, it works. A negative 6 and a positive 5 does equal negative 1. And then also check on equation C that it works for this. So 2 times the x value minus the y value minus the z value Does it equal -3? Well, this is going to be 2 minus 2, so that's 0. So it just leaves the -3 equal to the -3. Yes, it works. And so we have the solution 1, 2, 3.